Hello, everyone. So I'm really excited now to tell you about Meta, about the dev kit that we've been working on for a long time that's starting to ship, really about now. And, we believe very strongly that AR, and especially AR eyewear, which is what we do, it really opens new possibilities. New possibilities for how we interact with each other, for how we interact with, the world around us, and really is bringing computing forward a big leap. So, think about the Tony Stark desk. So our mission has really been simple. How do we bring that kind of Tony Stark world, that user experience, to everybody at a price that you can afford? And that's what we're going to be showing you, a demo of our steps to do that with our development kit. So think about it for a minute. We've been kind of held hostage to displays. Now, we love displays because we're buying more and more and more physical displays. But when we're in a physical display, in a laptop or on a phone, we're cut off from each other. We're cut off from the world. We're consuming massive amounts of digital content. But that is digital content that is not integrated. It's not integrated in with the physical world. How crazy is it when you think about the human visual system, all of our sensors, that when we actually want to find information, we have to type it into a Google search box. Well, imagine if you didn't have to type it into a search box, if you just had sensors sensing what's going on in the world and presenting you with relevant information affixed to the objects and tracking the objects in your environment. Well, that's what we're doing. That's what we're doing with the dev kit. And that's how we're bringing this Tony Stark world to you. So what do we make? AR eyewear, augmented reality eyewear. So this is not a VR device. It's an AR device. That means the glasses, you see through them. These are darkly tinted, but they don't need to be. We actually have displays integrated into the eyewear, and we have sensors all over it. And so that means that we've got 3D input. We've got to process it really fast. So we're using lots of GPU stuff, and then we get 3D output. And so that creates this experience in this environment, which is truly new. It's collaborative. It brings people together. Now, it's all built on a Unity SDK. So basically, you can take a Unity scene that you've built, a game, an application, and quickly adapt it. You replace the camera, integrate some UI components that we provide, gesture recognition that we provide, and boom, you've got an AR application. We're also providing some very simple apps, but these apps are just the building blocks to scratch the surface of the possibilities. So I'll introduce you to some of the people in our Pioneers program who are working with us in building a whole new ecosystem of AR applications on this platform. So it's a big claim, but it is the ultimate user interface. Why? Because it gives you what you've always wanted, what you've always dreamed of, superpowers. You can now have lots of sensors. Sensors are everywhere. And you can integrate those sensors into this 3D input, 3D output system. So this shows our dev kit, an early prototype of it. And it shows, the kind of Minority Report style. You got stuff coming in through the cameras, and then you can actually have a touch interface and interact with it. So engineers, architects, training, all sorts of applications where you want to be able to basically put objects in physical space, a true native 3D user interface that you can interact with. But then entertainment applications as well. So goodbye to the old cheesy kind of 3D movies. Let's have Jurassic Park running around your living room. You can actually walk around the dinosaurs, interact with them. That's the stuff that you can do. And you can have them tracked to the floor so that they're actually realistically walking on a physical floor, maybe hopping up onto a countertop. And then, of course, games. Actually being able to integrate those games, truly multiplayer things where you can see other people because it's see-through eyewear. Place game objects on walls, in the scene, on the floor, move around, shoot each other, virtual lightsabers. You get the idea. So how's it all work? How's it hang together? Well, as I mentioned, it's this 3D input, 3D output architecture. Sensor data coming in, gets processed from all sorts of sensors, processed from GPUs. Now, in the dev kit, it's tethered to a PC. But in production version that we're working hard on, imagine having a tablet without a screen. High-powered GPUs, crunching this, and integrating in multiple types of sensor data to be able to get the system going. Now, there's a whole lot that we need to understand around human-computer interaction, HCI. This is a new way of interacting, and we're hacking the human visual system and sensory system. And so there's as you know, there's a lot can go wrong with motion sickness, need fast updates on the GPU. And so those we're trying to address by understanding how do we perceive depth. We're doing very controlled psychophysical experiments around depth perception, around how we interact with stereo, around really how can, handling occlusion, making things natural and realistic and fluid. But then all of this is built on a bill of materials that is just repeated flips of Moore's law. That's happening now, and that's why this is exciting, because that's bringing this in at a price point that you can afford. So we're actually sold out of our dev kit. But we have some in reserve for partners that we're working with. So I want to take a moment and tell you a little bit about our partner program, our Pioneer program, because we're building this ecosystem for applications. And so what are we doing? Well, we've got people working with us on medical simulation, on strategic planning, architecture, all sorts of different applications there, but we're also working in parallel on games and other types of kind of fun applications as well. So I'll just give you an idea of what's going on in our partner program. I'll introduce Emily Bartell from Booz Allen Hamilton. She's come to a recent workshop with us, and she'll tell a little bit about why she's been working with Meta and what they're hoping to achieve. Emily.
Hi, so I am Emily. My colleague Andy and I guess, spent Saturday, Sunday, and Monday with the Meta guys. It was a really great experience. So I work for Booz Allen Hamilton, and we're part of a small team within the company that falls under a somewhat larger team called the Strategic Innovation Group. And what we're kind of tasked with is kind of forward thinking and how emerging technologies like this, how we can apply them to different areas and how we can really solve client needs with them. So I lead up the interactive media side of that. And we're about 50 so people-ish in that kind of situation. And we focus really on games and interactive media, web, mobile, and Sims. So a lot of what I do is kind of using augmented reality and virtual reality for training and simulation and education type experiences. And then the flip side of that is we also do a lot of analytical work. And so what Andy and I spent the last 2 days building was kind of a data viz application inside Meta, and taking data viz past Excel and past Tableau and letting you actually interact with the data. So part of the really cool thing is the hand controls and the ability to reach out and grab things. And we're trying to look at if we can actually interact with something as static as data, can you get more from that? And is there an emotional connection that you can start to draw on? So, as a partnership, we're really excited about, the potential of the technology, kind of the future that's out there and the stuff that we can build together.
Awesome, thanks a lot, Emily. Yeah, so as Emily says, this 3D device, it's got a unique way of really building an emotional connection, making content that can otherwise be dry understandable. And to tell you a little more about that, I'd like to introduce Mike Price to you, who's going to talk about what he's been working on with Meta in the Pioneer program in strategic planning. Mike, take it away.
Thank you, Soren. You may have just seen me a second ago on the screen. That was back in May when we did the original Pioneers workshop with Meta. My business partner and I founded a company to begin to work with augmented reality. He is a former general manager with Microsoft, and I was a former lieutenant colonel in the Marine Corps. We formed this company to talk about changing the way that people relate to information at the highest levels of government, as well as the levels of any sort of corporation, city, or any sort of collaborative planning endeavor. And that's what we're talking about, is collaborative planning. Nigel and I came up with the idea of using augmented reality, a lot of the gaming material that you're using today, and why not flip that? Why not flip that into the real world? Why not make it so that people that have to figure out multi-layered, complex, geographically oriented information, be it the invasion, be it building a new plant, or tracking whatever resources flowing around the world, and figure it out down to the minute scale. Suppose you own a ski resort, and you have a piece of land that you're going to look at. You use the actual imagery of that land in a 3D layer, and you have it sitting there before you. And as you see this land, you stand around the table. You stand around that table with somebody from state, somebody from the ecology, somebody from the landowners, the developer themselves, the contractor, everybody who has a stake in what you're talking about. And they can see before them a 3D hologram of everything that's on that land. That if you want to put, say, ski lift towers. You want to put them in a place, in a line. So you draw a line where you want this to go. You reach out using Meta's technology. You reach out with your hand and describe a line. And then you tap a toolbox and grab a ski lift. And the poles fall into place. The poles go exactly with the proper interval, terrain related, and at the right altitude. so that you can see exactly where this goes. So somebody standing there says, no, you can't put a pole there because there's this animal there, or because the terrain won't support that geologically. Now you're reaching down into a level of depth of planning and coordination that simply doesn't exist right now. Because the problem is that you go from PowerPoint on a 2D surface to with a couple of spreadsheets, and then you ask the seniors, the people who have to make the decision, to figure it out and make it work. And it doesn't. It falls apart because there's a pyramid of information that goes at the bottom from the experts to the people in the middle who have to integrate and to the people on the top who have to make the decisions. And along that pyramid, there's a real problem with information flow going upward. Because at the top, they're concerned about risk. And they've gauged that risk on priorities and resources. Authorities, risk, and resources are the primary sources of problems within the government. If you can see a holographic version of what the problem is, each layer from every perspective that you can actually reach in and control as though it were a game, using that same thinking, that same technology, and turning that into the real world, you have just now made it so that people that are educated to make these kind of decisions actually get the information that comes up from the bottom. Because every time when something like this fails, you see the experts stand there and they tell you that we told you this was going to happen. Now we can eliminate that mistake. And using Meta's technology, we look forward to helping our clients do a better job of planning and understanding how the world really works. Thank you.
Thanks very much, Mike. Yeah, so that's just a little bit about how not only is this technology fun and exciting, but it's truly useful in solving real pain points. And so we're working with Pioneer Partners. If any of you are working on any of these applications, training, simulation, please come talk to us, and maybe we can still get you a pair of Meta 1 glasses. But now enough talk. I'm going to turn this over to Alex, who's going to show you a little bit about how our Unity SDK works. And if all goes well, and we're not too cursed by the demo gods, a demo.
All right.
And, by the way, after this, if you're still interested, please come by our booth, and you can experience this demo firsthand yourself. Alex, take it away.
Thanks, everybody, for coming today. I imagine there's a lot of people here who are excited about AR and have been waiting for the real thing your whole life. I was somebody who pre-ordered some of the other ones that were supposed to do it, and they didn't do it, so I had to join Meta and make it real. This is the SDK. The SDK is available to our Pioneer program, and I'm going to show you what it can do live. So this is one of the example apps that comes with it. It's called the Meta SDK guide, and I can run it in the editor. I can run it in the build, maximize on play. And I'm going to enable the RGB mode. That black, oh, it didn't do that a second ago. Don't worry, it'll just restart. The black in the background is see-through. So whenever you're doing these types of augmented reality experiences, what you're going to be doing is black is see-through. But when you want to communicate to an audience, like yourselves, who aren't looking through the glasses, you hit F8 and the RGB feed comes in, which looks kind of cool because you're seeing two copies of reality through your eyes. But it makes a lot more sense to viewers who are just watching and trying to understand what see-through glasses means. So see-through is a really big difference from using a virtual reality helmet with the camera mounted on it. When you do see-through glasses, you're actually looking right through most of it. Anything that's black is see-through. And you see right there. OK. My head tracking isn't working. OK. So what you see right there black, I just see as nothing. So I can see you. And you see my fingertip is a little circle. Now, if I hit F8, we get RGB. So that is how this appears to me. Now, I want to go through some of the SDK features as a developer and learn how the SDK works. So as you can see, it just tracks my finger. So there's a whole sort of Lego piece set that you build your apps with. You start out by putting in one Meta World prefab, and that's like your Lego placemat. Then you attach all your objects to that. Then each of your apps is a Meta app, and this is a multi-app operating system environment that turns asset bundles into dynamically saleable commercial products that you can distribute to people throughout the world. So if they're wearing Meta glasses, all they have to do is put them on, and they will be able to buy your apps, which you make as bundles. So on top of your app, you need the components with which to build your SDK sort of building blocks. So the most basics of those are we call panels and holograms. So if you're used to Iron Man, our philosophy of design used to be what would Jace do, WWJD. And we were watching his films like Iron Man in slow motion over and over again to get a feel for how he did things. And now we don't have to because we hired him and he's our director of graphics. So we just say, Jace, what would you do? And then he does it. Okay, so the most basic one is called a meta body. So you're probably used to rigid bodies, right? Games are full of things that are unpredictable, which makes them fun. The things don't do what you want them to do, and that gives players a challenge to try to get them into the hole or get them to behave as they want. But Tony Stark kind of goes like that, and everything just reads his mind. So the idea of a meta body is that it is an intentional object. It's an object that appears to behave just the way you want it to. So our most basic types of behaviors that we see in Iron Man are things like grabs. So you see how that object built in just a bit at a time? It didn't just pop in. That is what we call jasification. And it's a bit hard to do with RGB feed turned on. Okay. Yeah. We have this working normally. Anyway, I can grab objects and move them around. And I can also jasify things. So an object like this, as you can see, it builds in slowly. So you kind of get an automatic hologram type effect. And yeah. And it also has mouse click support. So when you don't have your glasses plugged in, you can interact with all the stuff in the system. Now, okay, looks like my computer is a little unhappy. So I'm just going to show you a little bit more, but if you want to get the full live demo, you can come down to our booth. You can try the rest. I'm going to show you a little bit more about how the SDK works. So when you install it, what you get is a Meta exe, which is like the shell. So remember when Windows was an exe on top of DOS? That's what this is like, so that when you're using this tethered to a device, you plug in, and your apps can load into the Meta exe like an environment. You get a documentation and a Unity package that powers it. There's a built-in help that is going to guide you through how to use it. And you'll immediately see that we have a much cooler looking camera than the little tiny icon you're used to seeing. Our camera, the Meta World Prefab, actually shows you a three-dimensional model of everything that you see in the real world. And it breaks down basically into the depth sensor package, which is how it is able to perceive everything, and the glass screens that are little sideways projectors that it's trying to line everything up on. Getting the data coming in and the data that you see to line up perfectly is called rectification. And there's more of a detailed breakdown of how that all works. But it's basically left and right cameras, just like any other stereoscopic system, but combining that with the depth data. So the SDK documentation will walk you through how to use all this stuff and build your app up. The layer starts with, like I said, an app object. And then your fundamental building block is a meta body. So a meta body is a way of saving you the trouble of going through add component and being like, what does that do? And what does that do? And looking through the scripting reference and trying to learn everything. This has built-in help for all of the things in our entire SDK, right, attached to them. So anything you're looking at, there's help for it. And you only see as much or as little of the properties of interactivity as you're using. The scripts you write are called meta behaviors. So if you're used to mono behavior and lots of little nice touches that they had, like shortcut variables and all the events magically working, even though they're private. Do you ever scratch your head and ask yourself, how do private methods receive messages from update? It's magic, or reflection. So we replicated that, and you just basically change a mono behavior into a meta behavior, and it's enhanced with all the event handlers. Most of the events that you get are from Meta Gesture Manager. So Meta Gesture Manager gives you a high level, so you don't have to do any hand-finger manipulation type code. You have all the kinds of events of grabbing and releasing and pinching and dwell timers and gaze-based stuff for eye tracking-like behavior. It is all as simple as writing a handler method. Now, you also have the ability to go in. So this gives you full CS access. If you want to write OpenCV plugins, do your own custom machine vision, or if you're already working with companies that have their own in-house stuff, you can combine this with other AR SDKs and with your own custom plugins. And you can get direct access to all the raw data that is coming out of the algorithms that we provide. So the final framework, I showed you a little bit of it. MGUI is the WWJD thing. And this is where we're going with it. We have demos in-house that look more and more like Iron Man in real life. And that is where we're going with it. All the things you need to build, we have special optimized prefabs, which are all using UGUI, as well as, have you ever noticed that the standard cube is a meter across, which doesn't work too well when you're building things that fit in your fingertips? So we have special meta primitives to replace all the cubes, spheres, and things with default grabbable, beautiful holographic objects. And we also have tracking. So we're all used to markers, and you can calibrate to those. They're very handy for identifying very specific spots and lining things up. But we also have depth tracking. Depth tracking means we're not using RGB all the time. We're actually looking at your surfaces. So I can take a surfaceless or a featureless white table with nothing on it, and I can put an object on it and get closer to it and do full head tracking around it without the use of any RGB features, which is a first in our industry. This is the beginnings of what is ultimately a metaspace environment. So your apps are going to be able to load not only for your early enterprise type applications or your in-house use where one person is running one exe. You're going to be able to just hit upload to the App Store, and people are going to be able to see all of the apps you've created, load them into their belt menu, and have all the apps that they want to have take with them or put them on their walls and decorate the whole world around them with what you have created. And this is our SDK. We've worked really hard on this for the past year and a half to make this very Unity-like and to stand the test of time. But we also want to get your feedback. So the Pioneer program is the best way to get involved right now if you want to get glasses early. You can come down and check out our demo, and you can see what this is like and get on the SDK yourselves and start making apps. Thanks.
All right, so we got a few minutes left for questions. We've also got our CTO, Ray Lowe, with us. He came out of Steve Mann's lab, where he's been building prototypes of this for quite a long time, and so he's probably 8 years. So yeah, happy to take any questions to any of us or to Mike or Emily. Going once, going twice.
I actually met a lot of you today. Like, I gave a lot of demo personally, and I'm very happy to be here because all the great feedback, oh my God, actually. Especially some of the time, today we have a rough demo, but regardless, I'm thinking the future of the industry is where we have digital content you can really, really engage with. Away from the flat panel this time, you actually touch it. I think I can interview some of you at the end to say this will be something very exciting. And this is something I really would like to add. Yeah.
All right, well,
Actually, I want to ask one question. For example, actually I have a demo with you recently with these eyeglasses. Can you give us like one example that you would like to build application on? For example, like, so yesterday you asked like, for gaming industry, for example, people have been dreaming to create virtual content that live around you. And would you have like any feedback on what you think this could be?
Yeah, I think starting by the detection of the environment, and you can get information from the environment, it should be really awesome. But I would like to see that working, you know.
Yeah. All right. So that's exactly, yep.
Yeah, we have integration currently demoed that we showed at GDC of playing Connect 4 with a cube that automatically synchronizes between the two players' worlds. Connect 4 was perfect because it fits right between where you're both reaching if you're sitting down. But you can do bigger, more room-based stuff with the SLAM technology we're doing next.
So, one more. I saw the marker head tracking. Are you guys going to do feature tracking too?
Yeah, we're doing more than just feature tracking. Ray is the algorithm master. Could talk about
So direction of the company, one thing you see is really structural based. So we can look into surfaces like even a piece of paper. I can turn it into interactive content. The reason it works is actually we're using actually a time-of-flight camera that provide that information. So that actually, you don't see it in the industry today because these technology are the first time in such a packaging, and that's where the excitement comes in. And any questions? Yeah. Yes.
I was wondering, like, are y'all gonna make the inputs that maybe work whenever other people, developers, kind of set it up to work with other AR input and integration? We all try to make some of those shared.
like rings or wristbands or stuff like that? Like the thalamic wristbands or the rings or stuff?
Like you were talking about integrating other AR packages.
Oh yeah, definitely.
Yeah. So we try to provide the IMU data at 100 hertz, and all the sensor data is subscribable to any vision library that wants to consume it and do more analysis. And we try to make that as open as possible so that we can build this ultimate kind of metaverse reality that we're all kind of pioneering together. It's a very, very exciting time.
Yeah, at the same time, we're also providing Adobe Sound Engine, so you also have 3D sound with the system. So we're actually working very closely with lots of partners to ensure that our platform will support the state-of-the-art technology.
Yeah.
Yes.
I see currently the glass is wired. Will you do wireless?
Yeah, that's a very good question. People ask, like, when is the untethered version? The direction of the company right now, we're building a developer platform. I want to have the most powerful eyeglasses at the moment, which give developer access to all the features you can dream of. We're an enabler at this time. I want people to create the best experience. And that's the direction we're aiming at, miniaturizations, power consumptions. We're working really hard every day to get to that point, and it's coming up. Of course. Yeah. Any more questions?
Probably last question.
Last question?
Last question. If there's no more questions. Oh, yeah, one more.
Is there anything in your SDK that includes eye tracking?
We have a thing called Gaze. And so you can enable touchable, gazeable, pinchable, grabbable. All of these are there. Currently, the gaze is based on the center of your field of view. However, with eye tracking in the future, it becomes possible to have that move around.
I'll get back to you, yeah, one-to-one. I'm listening to feedback from actually lots of individuals as we're shipping eyeglasses. We have a priority list of all the features as we come along. So definitely come to me. I'll put it in and then make sure that we work with the best technology together. Yep.
I just was gonna say I demoed it this morning and I demoed like 6 demos down there and there was no crashes. So probably
Yeah, it normally works. We just got this box and
Okay,
haven't tested
so-
before. Thanks.
Okay, thank you. Yeah, we do have a demo here. I would like to introduce everyone who haven't tried our demo and try it. And I met him this morning, and then he says, "Oh my God, this is the coolest thing ever." I don't want to say it from my mouth. I want to hear from you guys, and I want to take some negative feedback, positive feedback, and then we'll make it the best platform for everyone. That's what we do. Yep.
All right, yeah, thanks everyone for coming. And come by for a demo.